Our solar system is made up of 8 planets orbiting the sun. But have you ever wondered how it got that way? That's what's up next on PS 100. Your brain is lazy, and so is mine. But that's not entirely a bad thing. All it means is that the human brain does its best to automate everyday processes. And the more familiar something is, the more likely we are to take it for granted. Like our solar system, for example. We've all seen it depicted in models like this. In the center, you'll find the sun, the largest body in the system. The next 4 spheres are the terrestrial planets, made primarily out of rocky, high-density materials. Then you have an asteroid belt, and then the Jovian planets, massive gas planets composed mainly of gas. And then you've got Pluto, which is well, let's not go there. It's kind of a sensitive subject. Anyway, like I've said, models and pictures of our solar system are so familiar to us that we may not have bothered to ask some of the most basic questions about them. Like, why do all the planets orbit around the sun on the same plane? Why is the sun so much bigger than everything else? Or why are the planets nearest the sun so small and rocky while the ones beyond the asteroid belt are so big and gassy? When you think about it, the root of all of these questions is one big question. How was our solar system created? And since the 18th century, scientists have been working on an answer that they call the nebular hypothesis. It's still a work in progress, but this is what they've come up with so far. About 4.6 billion years ago, our solar system was just a rotating nebula, a spinning cloud of gas, ice, and dust. Then, over the course of millions of years, gravity began to pull the cloud towards its center where bits of matter began to clump together. As the gravitational potential energy of the particles surrounding the core was converted into kinetic, or moving energy, they produced more and more heat. Meanwhile, thanks to the conservation of angular momentum, which we covered in another video, our nebula started to spin faster and faster. So fast, in fact, that the outer regions flattened into a disk pattern the same way pizza dough flattens out when you spin it in the air. Then, when the core of the nebula had been balled up so tight by its own gravity that its internal heat and pressure became intense enough to start a fusion reaction, a star was born, our sun. But let's rewind. While all this was happening, the material that ultimately became our planets was also beginning to stick together in their respective orbits. Because gravity pulls everything in toward the center, the sun ended up with the lion's share of the nebula. But the bits it left behind were gradually colliding, forming bigger and bigger chunks of matter until they ultimately formed the spherical planets we know and love today. So why are the terrestrial and Jovian planets clustered into 2 distinct groups? Well, gas doesn't stick together very well, and you need a massive solid object to hold on to much gas with gravity. In contrast, solid matter sticks together quite well. So, if planetary formation depends on the presence of solids, then whatever material is solid in a given region determines which sort of planet can be formed. In the warm inner region of the solar system, the only things that could stay solid were the elements with high melting points that combined to form our rocky inner planets. But there wasn't enough of that sort of material to create planets large enough to pull much gas in with gravity. In the outer, cooler regions, molecules that naturally occur as gases on Earth, like methane, ammonia, and water, exist as frozen solids. And as solids, these elements could stick together with other solids to form massive, solid cores with enough gravity to sweep up all the gas in the neighborhood. And that's how we got the gas giants, Jupiter, Saturn, Uranus, and Neptune. And there you have it. The nebular hypothesis. That's it for this episode. For more science and research opportunities for BYU undergrads, be sure to check out the links in the description below.